Today we will be starting a new learning target, 7E absolute value functions. So take a minute to get your Cornell notes set up. What is absolute value? Absolute value is the distance away from zero that a number is. For example, if we look at positive 6, it is 6 units away from zero. And negative 6 is also 6 units away from zero. So the absolute value of 6 is 6, and the absolute value of negative 6 is also 6. What notation do we use to represent absolute value? The notation we use is 2 vertical bars around a number or expression. Let's not confuse this with parentheses. Absolute value are 2 vertical bars, so straight up and down. Let's look at these examples below. So the absolute value of negative 2 has these 2 bars to represent absolute value. And it is equal to positive 2. Because anything that is within the absolute value lines becomes positive. So anytime it's a negative number, it turns positive. Or if it's already a positive number, like this 200, it stays positive. What is the general form of an absolute value equation? It is very similar to what the equations we have been looking at the past couple weeks. We still have our vertical stretch as A. We have our h value as the x value of our vertex. And we have the k value as the y value of our vertex. So one thing to note is that we are still flipping the sign of the h value. So in the equation, it is a negative h, but when it goes into the vertex, it becomes a positive h, because that sign flips. Let's look at an example. We're going to get out our calculator and let it help us graph this function. So I'm going to go to the y equals first, and then I'm going to hit the math button, just like we did for cube root functions. It is right under the green alpha button. I'm going to arrow over to where it says number, and it's the first option, the ABS, and I'm going to select it. Then I'm going to enter in my equation. So it's y is equal to the absolute value of x. So I'm going to enter in x, close my parenthesis. Then I'm going to graph it, just to get a general idea of what the graph looks like. Now I want to look at the table. So I'm going to go second, graph. And I'm going to look for the vertex. The way that I look for the vertex is going to be to find 2 y values that are symmetrical around an x value. So for example, let's look at the value x equals 0. If I arrow over to the y values, I see that there's a 1 above and a 1 below. So that tells me that 0, 0 is going to be my vertex. Those 1s, those are symmetrical values. So there will be symmetrical values around whatever your vertex is going to be. So that will help you locate your vertex in your table. So let's graph our vertex. 0, 0. And then let's graph some other points. Some points in the table below my vertex are 1, 1, 2, 2, 3, 3, 4, 4, and so on. So I put an arrow to show that that line will keep going. If I look at the table the x values below my vertex, I see that it's going to be negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, and so on. So again, I can draw the line with an arrow to show that that line will keep going. So now let's talk about some key features of our absolute value function. We already said the vertex is 0, 0. Now let's talk about the domain. If I look at this function, this first line right here is going to go on forever in the positive infinity direction. If I look at this line, it's going to go on forever in the negative infinity direction. Therefore, I know my domain is going to be all real numbers. Anytime I have an absolute value function, it is going to have a domain of all real numbers. So for the range, I'm going to look at my lowest point on my y-axis, which right now, it's at y equals 0, because that is where my vertex lies. So all of my y values are above y equals 0. So I know that my range is going to be y is greater than or equal to 0. I can also look at my function to get this information. So I see that there are no h or k values in my equation up here. There's no h and there's no k. So therefore, they are equal to 0. So that is how I can get a vertex of 0, 0. Like I said, my domain's always going to be all real numbers. And then my range, I can see from the a value. So right now, our a value is a positive 1. So that's going to tell me that since it's positive, it's going to be greater than whatever value the vertex is at. If it was a negative, it would be less than whatever y value the vertex is at. And you will see an example of this coming up. Okay, so here's another example. We're going to pull out our calculator and enter in the equation. So let's go back to y equals, clear it out, go to math, arrow over, and enter, because it's the first option, ABS. Now I'm going to enter in x, subtract 5, close my parenthesis, subtract 2. And then I'm going to graph it to get a general idea of my graph. So I can see that my vertex is going to be in the positive x values. So that will give me an idea of where to go in my table. So let's go to the table, go second, graph, to get my table. So now I know that my vertex is in the positive value, so I'm going to go down until I see a value where there's symmetrical y values. So I see that at x is equal to 5. If I arrow over, there's a negative 1 above it and a negative 1 below it. Those are the symmetrical values that we are looking for. So my vertex is going to be 5, negative 2. Now let's graph that. Over 5 and down negative 2. Let's graph some other points. So 4, negative 1, 3, 0, 2, 1. Whoops, that's supposed to be right there. And then if I go up one more, I'm at 1, 2. So let's look at some values below our vertex. So here I have 6, negative 1, 7, 0, 8, 1, and 9, 2. So if I draw in these lines, they're going to keep going in both directions. So I have to have those arrows on there. So let's write our key features out. We said our vertex is at 5, comma, -2, which I can see from my h value and my k value. Don't forget to switch the sign of the h value. My domain is going to be all real numbers. And my range is going to be y is greater than or equal to -2. Because that is the lowest y value on my graph. I can also get that number from the y value of the vertex. Here is one more example. Pull out our graphing calculator again and enter in our equation. So y equals, we're going to go to math, arrow over to number, select the first option for absolute value. Oops, don't do that. Notice that there is a negative sign right here. So we need to put a negative sign in before we put the absolute value. So we want to select the negative sign. Now we want to go to math. Arrow over to number and select absolute value. And then we want to complete our equation. So x plus 1, close my parenthesis, plus 3. And let's take a look at the graph. So I can see my vertex is going to be in the negative x numbers. So if I go to my table, I'm going to go to the negative numbers and look for my symmetrical values, which I can see right here at x is equal to -1, because there is a 2 above it and a 2 below it, the symmetrical value that we are looking for. So my vertex is going to be at -1, 3. -1, 3. Okay, and then let's graph some more points. I see one at -2, 2, and -3, 1, -4, 0, and -5, -1. We're going to draw in our line, put an arrow because it keeps on going. And let's graph some points on the other side of our vertex. So I see the point 0, 2, 1, 1, 2, 0, 3, -1. So we can draw in our line with our arrow to show that that line keeps on going. So for our vertex, which we found from the table, but we can also see from our equation, it is going to be -1, 3. Our domain will be all real numbers. And our range is going to be y is less than or equal to, because we have a negative a value, so y is going to be less than 3, because 3 is the y value of our vertex, and that is the highest y value that we have on our graph. So that is how we got our range. Here are a few example problems for you to try. So get out your notes, attempt these, and ask questions to Mr. Dunn, Mr. Braytek, or myself.